Hello everybody, today we're taking a look at the Chapter 3 study guide. So we take a look at the first learning target. It says, I can understand that subtracting is the same thing as adding the opposite. So we're going to rewrite each subtraction problem as an addition problem. So let's take a look at this first one here. We have negative 10 minus 9. I want to write this as an equivalent addition problem. And so I know that subtraction is the same thing as adding a negative. So that's what I'm going to change it to. Instead of subtraction, it's going to be negative 10 plus negative 9. And we'll see that in both cases, negative 10 minus 9 gives us negative 19, and negative 10 plus negative 9 also gives us negative 19. So we see that they are in fact equivalent. All right, let's take a look at B. We have 12 minus 4. Again, subtracting is the same thing as adding a negative. So we're going to stay with 12 to start, but now it's an addition problem, and we're going to make this negative 4. 12 plus negative 4 would give us positive 8. We don't even need to write the answer. And then we have part C, 14 minus negative 4. Now remember, when we are subtracting a negative, it's the same thing as adding a positive. All right, so subtraction and negative is the same thing as adding a positive. So that's what my new problem is going to look like. 14 plus positive 4. All right, so we finished that first part. Now we can scroll down here. And we're looking at problem 2. I can subtract integers. So here we're going to use some methods. We might want to rewrite them as addition problems. And then we also could use number lines. And we could also use diagrams with tiles. Or we could use the methods we learned about. So let's go ahead and look at A. We have 42 minus negative 10. So I like to change this to an addition problem, and I know that subtracting a negative is the same thing as adding a positive. So I'm going to rewrite this as 42 plus positive 10, which would give me 52. Moving on to B, negative 21 minus 6. So I'm going to write this as negative 21 plus negative 6. Now, since these both have the same sign, 21 is negative and negative 6 is negative, I would add them like I normally would and get 27. And then I'm going to take the sign of both numbers, which would be a negative. In other words, if I owe $21 and then I owe another $6, I owe a total of $27. That's why it's negative. Now we're looking at part C. So it says 2 minus 14. So I'm going to change this to addition. Rewrite it as 2 plus negative 14. And remember, when I have a positive number and a negative number, I want to find the difference between them. Okay, so what's the difference between 14 and 2? We're looking at absolute value here. So the difference between 2 and 14 is 12. And now we have to figure out, is it going to be a positive or negative 12? Well, if we take a look at negative 14, it's negative. And since 14 is a bigger number than 2, we're going to take the sign of our larger number in terms of absolute value. So our answer is going to be negative 12. Basically, all it's saying here is, do we have more negatives or more positives? And obviously, 14 negatives, if we were to draw them out, is more than just 2 negatives, or 2 positives, excuse me. All right, so that's why our answer is going to be negative. So we had more negatives than positives. All right, looking at the next problem here. Problem D. 63 minus 21. When we rewrite it as 63 plus negative 21. So here we have different signs, positive 63 and negative 21. So we're going to find the difference. So 63 minus 21 gives me 2, 4. 42 is my difference. What sign is it going to take, positive or negative? Well, 63 is the bigger number in terms of absolute value, and since it's a positive 63, my answer is also going to stay positive. Problem E. I'm going to start with negative 32, and I'm going to change this to plus positive 23, right? Subtracting a negative, same thing as adding a positive. And since we have a negative and a positive number now in our addition equation, we're going to find the difference between them. So 32 minus 23 should be 9. And now, is it a positive or negative 9? That's the question. Well, in terms of absolute value, negative 32 is the bigger number. So that's negative 32. So my answer is also going to be negative. I have more negatives in my problem than positives. All right, moving on to the next section. I can multiply positive and negative integers. So remember here, if we have what's going on? My marker is like disappearing. Let me try this again. Okay, let's go purple. Maybe that'll work. Cool, it's working because I changed the color. All right, so if we have an even number of negative factors, then our answer is going to be positive. All right, so an even number of negative factors, answer is going to be positive. If we have an odd number of negative factors, then our answer is going to be negative. Okay, so it's all about even or odd number. So I'm going to go ahead and circle all my negative products in all these problems, just so that way they stand out and I don't miss them. All right, so here do we have an odd or even number of negative factors? Odd. Next we have even, odd, even. This one we have none. So if we have an odd number, it's going to be negative. Even number, it's going to be positive. Odd number, it's going to be negative. If we have none, that's just 4 times 2, so that's going to be positive. And then even, number of negatives here, negative 4 times negative 4, so that's going to be positive. Okay, so we have our sign completed for all these problems. And now we can just treat them like normal multiplication problems. So 3 times 8, 24. 11 times 5, 55. 7 times 5, 35. 4 times 2, 8. Negative 4 times negative 4, positive 16. Cool. Now we're looking at find the product of decimals. So here we're going to multiply decimals, which again is really just like multiplying whole numbers, because we're actually going to change these into whole numbers. So 4.2 times 6.3, we can really think of as 42 times 63. All right, so let's go ahead and let's start. 3 times 2 gives me 6. 3 times 4 gives me 12. Done with my 3. Now I need to put a 0 down here, and this is a placeholder. Why is it a placeholder? Well, because we're done with the ones place. All right, we already did 3 times 42. That was our first operation. Now we need to do 6 times 42. And really, this isn't 6. It's 60 times 42, because we can break apart 63 into 60 and 3, which is what we're doing in the standard algorithm. So that's where this placeholder comes from, because now we're moving on to 60 instead of just doing 3, which is a ones place. All right, so we do 6 times 2 to get 12, carry the 1. 6 times 4 is 24 plus the 1, 25. Now we can just add straight down. 6 plus 0, 6. 2 plus 2 is 4. 1 plus 5 is 6. 2 plus 0 is 2. So 2,646 would be my final answer. Wait, is it actually my final answer? Hold on, what are we multiplying? So we're multiplying decimals, right? So we have a decimal here, we have a decimal here. So if we look at the first number here, 4.2, we had to move this one place to the right to make it a whole number. And then for 63, we had to move it one place to the right to make it a whole number. So we moved the decimal place 2 places to the right, which means now we need to put the decimal back in by moving it 2 places to the left. And the reason we go in the opposite direction is because if you move something to the right, like you push a chair off to the right side, the only way you're going to get the chair back in place is if you push it back to the left side. All right, so that's why we're doing the opposite here. So we move it 2 places to the left. We end up with 26.46. My final answer. Moving on to part B. And you can go ahead and check your work here with the calculator after you show all of your work. All right, part B here. Again, we're going to ignore that decimal place. We're going to move it to the right, push it out of the way. So I'm going to move 2.13, push that 2 places to the right. I'm going to move this 0.7 1 place to the right. So 2 places to the right and 1 place to the right, for a total of 3 places to the right, which means I'm going to have to move 3 places to the left when I get my answer. All right, so 7 times 213. 7 times 3 is 21. Carry the 2. 7 times 1 is 7, plus the 2 is 9. 7 times 2 is 14. And that's all we have to do. So we have 1491. Where's that decimal going to go? 1, 2, 3 places. So our final answer would be 1.491 instead of 1,491. All right, now we're looking at question C. We'll do purple again. So here we're going to move the decimal place 1, 2 places to the right. Move the decimal place 1, 2 places to the right. So move it 2 places to the right here, 2 places to the right here, for a total of 4 places to the right. So when we get our answer, we're going to move the decimal 4 to the left. That's when we get our final answer, because we're undoing what we did before. All right, so here we go. We got 13 times 29. So we have 3 times 9 gives us 27. Carry the 2. 3 times 2 is 6, plus the 2 is 8. So now we're done with the 3. Put my 0 down here for my placeholder. Now moving on to 10. 10 times 29. 1 times 9 is 9. 1 times 2 is 2. So now my problem reads as 87 plus 290. 7 plus 0 is 7. 8 plus 9 is 17. Carry my 1. 1 plus 2 equals 3. So my final answer for this part would be 377. But let's look at how many places I moved the decimal. 4 places to the right, so I need to move it 4 places to the left to undo what I did before. So my decimal points here, move it 1 place, 2 places, 3 places, 4 places. I would put a 0 in here. So my final answer would be 0.0377. All right, now we're moving on to part 3. I can apply the order of operations using parentheses, addition, subtraction, multiplication, and division. Now notice this isn't the order that we would actually solve it in. We would rather go parentheses, exponents, multiplication, or division. That's all one step. Adding or subtracting. All right, so again, this is whatever one comes first from right to left, multiplication or division, and then after that step, adding or subtracting. Okay, so let's start with parentheses here. Do we see parentheses? Oh, I do. I see parentheses here. And this here is not really parentheses, that's multiplication. So we don't need to do anything there. So let's start with parentheses. We're going to rewrite it as 2, and then 9 plus negative 5. Well, we're going to find the difference between 9 and 5. Take the sign of the larger number, which would be positive 4. But we don't need those parentheses anymore, so we're going to go ahead and erase those. And remember, 2 on the outside of the parentheses, that's the same thing as multiplication. So you could write multiplication like that, or you can also write multiplication like this. Okay, so when you see that 2 on the outside of the parentheses, that's saying you multiply whatever in the parentheses by 2. Minus 8 plus 4, and again, since the 4 is right next to the 3 in parentheses, that means multiplication. So we have 2. So we're done with parentheses. We're looking for exponents. Do we see any exponents? I do not see any. So now we're moving on to multiplication or division. I do see multiplication here, and I see multiplication here. So 2 times 4 would turn into 8. Write everything the same. Oh, but then we have 4 times 3 as well, which should be 12. So now we have 8 minus 8 plus 12. Moving on to the last step, adding or subtracting. Well, I see subtraction first, so I'm going to do that. 8 minus 8 gives me 0, and I still have plus 12, and this is my final answer would be 12. All right, now moving on to part B. So since these 2 groups of parentheses are right next to each other, that's going to tell me multiplication. If there's no sign in between, that means multiplication. So we're going to do the parentheses first. So we have 9 minus 5 gives us 4 inside of those parentheses. And then we have the other set of parentheses, 2 plus 3, which should be 5, minus negative 1. And let's just remember that negative 1, subtracting it is going to be the same thing as adding positive 1. So it's really 5 plus 1 if we wanted to rewrite it. And then if we were to do 5 plus 1, we get 6. So now we have 4 and 6. Remember, that's the same thing as saying 4 multiplied by 6. So we can actually rewrite it as 4 times 6. And that's going to give us 24. All right, moving on to the final problem here. So again, parentheses, exponents, multiplication, division, adding, subtracting. So we have multiplication here, and we have division here. So we're going to turn into 6 plus 12 minus what 10 divided by 5 would be, which would be 2. And then we're going to do adding and subtracting. So 6 plus 12 gives me 18 minus 2. So that's going to give us 16. All right. Now we're looking at part 6. Find the quotient for each problem below. So again, we're going to kind of ignore that decimal points. So I have 4.362 on the inside of my division. And then my outside number, my divisor we call it, is 3.3, 4 points. Okay, so we want to make it so this divisor is a whole number, which means we're going to need to move that decimal place over. So let's go ahead and do that. Move it one place over. What we do to the divisor, we also have to do to the dividend on the inside. So now this problem looks like 3 on the outside and 43.62 on the inside. These here are equivalent problems because we move the decimal point the same place from the outside number as the inside number. So let's go ahead and solve this. 3 goes into 4 one time. 1 times 3 is 3. Subtract. It's going to give us 1. Bring down our 3. 3 goes into 13 4 times. Multiply it by 3, we get 12. Subtract it. We have 1 left over. Bring down our 6. 3 goes into 6 5 times. If we multiply 5 by 3, we get 15. Bring down our 2. So now we have 16 minus 15, 1, 2. 3 goes into 12 4 times. There we have a remainder of 0, so we know we're done. And we need to figure out where we're going to put that decimal point. So our decimal point is here originally. So we're just going to bring it directly up and put it in between. So it's 14.54. All right, next problem here. We have 7.28 divided by 0.04. Again, we want to move that decimal point on the outside number, so it's at the end. So we had to move it 2 places here, which means we also have to move the decimal point 2 places to the right over here. So now we could rewrite this problem as $728 divided by 4. Okay, we can actually get rid of the 0 for now. And so we're going to say, how many times does 4 go into 7? Once. 1 times 4 is 4. 7 minus 4 is 3. Bring down our 2. How many times does 4 go into 32? 8 times. 8 times 4 gives us 32. So we have 0. All right, and then we have to still look at how many times does 4 go into 8. We can't just forget about the 8 here because we still have to do 4 into 8. Should be twice. 2 times 4 gives me 8. So there we have a remainder of 0, and we have no more numbers left after this. We could write 0, 0 if we wanted. So I'm going to bring that decimal point up, and so my answer is going to look like 182. All right, so 0.04 goes into 7.28, 182 times is what it's telling us. All right, let's keep going. Okay, so here we're dividing fractions. Remember, that's multiplying by the reciprocal, otherwise known as keep, change, flip. So we're going to keep that first fraction how we see it, 3/5. We're going to change the division sign to multiplication, and then we're going to flip that 4/7 and make it 7/4. Now we're going to multiply across the top. 3 times 7 is 21. Multiply across the bottom. 5 times 4 is 20. And then if we were to write this as a mixed number, it'd be 1 and 1/20. All right, because 20 goes into 21 once, and there's 1 left over. And of course, it'd be over 20 still. All right, now we're going to do the same thing here. Keep, change, flip. But notice we have these big whole numbers in front, which means we have mixed fractions. And we need to get rid of those before multiplying, so we're going to turn them into improper fractions. So we're going to do 6 times 2 to get 12, and then add that 2 on top. All right, so one more time what that looks like is you're going to do this whole number multiplied by your denominator. So 2 times 6 gives me 12. Then I'm going to take 12 and add it by that top number to get 14 on top. 6 is going to be on the bottom. Change my division sign to multiplication. Do the same thing over here. This time it's 2 times 4 to get 8. Then we have to add that 1 on top. 8 plus 1 equals 9. So it's going to be 9/4. Okay, I'm going to look, can I simplify before I multiply? So here I have 9 and 6. So this would turn into 3/2, because 9/6 is equivalent to 3/2. And now I can multiply across the top. 14 times 3. So you know what, I can still simplify. I can divide 14 and 4 both by 2. That gives me 7 and 2. 7 times 3 on top, 21. 2 times 2 on the bottom, 4. 21/4, write it as a mixed number. So 4 goes into 21 5 times. 1 left over, so it'll be 5 1/4 for question D. All right, let's keep going. So these are some real-world math problems. This is where we can apply the skills that we just learned to real-world situations. So we solve the following real-world math problem. Tom is making trail mix. Delicious. He has 3.5 cups of peanuts to use. So that's what we're starting with here, 3.5. He wants to put 1/2 cup of peanuts in each bag of trail mix. So we're going to divide that by the number of cups it takes to make each bag. So here I have my mixed fraction. I want to change this to an improper fraction. So 2 times 3 equals 6. 6 plus that 1 on top gives me 7, and it's going to be over 2. So here we have 7 over 2, and then I'm going to change and flip, multiplied by 2 over 1. 7 times 2 equals 14. 2 times 1 equals 2. 14 divided by 2 equals 7. So it takes 7 bags that he can make. There were a total of 50 pieces of candy in the bag. 3/5 of the bag was full of Tootsie Rolls. How many Tootsie Rolls were in the bag? All right, let's think about this as a proportion. So the total, which would be on the bottom, is 50 pieces. That is my fraction or my ratio. And then it says 3/5 of the bag was full of Tootsie Rolls. So these are equivalent, all right, because it's saying 3/5 of the bag is full of Tootsie Rolls. If there were 50, how many would that be? How many would be Tootsie Rolls? And so here I'm going to say, how many do I have to divide by to get to 5? Well, I'd have to divide by 10 to get to 5. So that means I'm also going to have to divide by 10 up here. And another way that I could write this would be 3/5 multiplied by 10 on both the top and the bottom. Oh, trying to draw here, something's going on. Try this one more time. 3/5 multiplied by 10 equals 50 on the bottom, obviously. And 3 times 10 on top would be 30. So these are equivalent fractions or ratios, which means 30 Tootsie Rolls are in the bag. All right, now it says I can find a missing number on a number line. Complete each scale by labeling the remaining tick marks. So here, I'm going to look at the space between 40 and 24, which is going to give me 16. And now I'm going to do 16 divided by the number of marks here. 1, 2, 3, 4 spaces. 16 divided by 4 equals 4, which means if I count up by 4 on each of these lines, so 24 goes to 28, 28 goes to 32, 32 goes to 36, then I'm going to end up going up by 4 each time and end up at 40. So that's all good there. This next one here, I'm going to look at what's the difference between negative 16 and 0. Or I can look at the difference between 16 and 0. 16 minus 0 equals 16. There's 1, 2 spaces between 0 and 16. So I'm going to do 16 divided by 2 to figure out how much each tick mark goes up by. That gives me 8. So I can go ahead and fill in the numbers now, counting up by 8. 0, 8, 16, 24, 32, 40. Same thing over here. It's going to be the same numbers, but this time negative. So I'm counting down by 8 or adding negative 8. All good there. Final part here. Here we're looking at how many spaces are between this and that. 3 spaces. I know 0 is going to be here because that's where our graph starts. So I'm going to do 15 minus 0 to get 15. That's the space from here to here. And then I made 3 total jumps, so I'm going to divide it by the number of jumps. That gives me 5. So I'm going to count up by 5s here. This will be 0, 5, 10. Now over here, I'm going to have to jump 1, 2 times. And the space between is 0 to 4, so that'd be 4. So 4 divided by 2 gives me 2, which means that 2 would be my missing number here. All right, one more time. In this case, I'm going to count up 1, 2 jumps. And we're going up a total of 20. So I'm going to do 20 divided by 2, which gives me 10. So we're going up by 10 each hash mark. That's what it tells me. 10, 20, 30, 40, 50. And you can always just check your work by looking to make sure that this makes sense. You're going up by the same number each time. So again, one more time, you find how many jumps you have to do in between. So like in this case, it's 2. And then you have to find the distance between your first hash mark and the next hash mark number you're given. So in this case, 20. And then you divide your distance by the number of jumps you make. And that gives you how much you're counting up by. All right, hopefully this video helps. Real quick on 8b, I just want to give you the algebraic way of solving, how you might see it in algebra. So here you'd set up a proportion just like I did before. So I'd say 3/5 of the bag is full of Tootsie Rolls. If there were 50 pieces of candy, how many Tootsie Rolls were there? So I would put X in. And you can do something called cross multiplication. So I can do 5 times X and 3 times 50. So now I have 5X equals whatever 3 times 50 is, which is 150. And now I have to try to get X by itself. So I would divide 150 by 5, divide 5X by 5. So I have X equals 30. And this is just a quick look into algebra. I don't need you to do this for the test, but you are going to get the same answer as if you set it up the other way. Basically, all I'm doing here is putting a variable in for the Tootsie Rolls. In this case, I chose X, but it's the same problem that we did before. All right, hopefully this video helps. Please let me know if you have any questions. Good luck on the test tomorrow.